Yeah, you know, it's funny that we're talking about power, um, uh, because you know all the power issues that Texas has had this week. I can say chat, but I'm present. Dustin, yeah, I got you, Dustin. Okay, all right. So I'm going to close out my email so we don't reveal any super secret stuff. I can see chat over there, guys. So um, don't don't hesitate to ask questions multiple times. I'm kind of wondering. Let's see. Can I edit the description? Delete. I don't know. The latency. I'm going to leave the latency alone, just in case it messes things up. There's no sense in tempting fate. Okay. Um, okay, Krister Sims. I don't see him, but actually, definitely, you know, have him wave his hand. You know, do what have some. Um, so anyway, for those that haven't been here, those that I don't remember exactly who was and who wasn't, we went through creating and controlling a motor, and we used the IDE to do that, and then we did the is it in here? We did the second lab, which for some reason I'm not seeing. Um, yeah, we did the drivetrain. That's right. We created the drivetrain last time. So those that weren't here last session need to create the drivetrain. Um, and Enrique says he is here. Okay, good deal. Um, let me go ahead and take care of Enrique real quick, and then I'll get started. Come on, come on, come on, come on. Put the password in 3 times and all right. I guess I'll go ahead and bring the gradebook back up. And of course, it's kind of slow sometimes, but all right, Enrique Leon. Yeah, I got you down, Enrique. You're here. Okay, so on my screen, guys, we've got some things. Let me make this big. So you guys can see it. We're gonna talk about power sources, and we're gonna do this probably, you know, this session and maybe next one, or maybe I'll give some other stuff. But there's some information here that you can click on these links, and you might get a little more insight. This right here is a bunch of solar panels, and you can't really see them too well in a clean room. That they were using for power. Power is gained through various different means, and we'll talk more about this. The most common way to power a robot is through batteries. I mean, that's basically the main thing. You know, whether it's an RC car or whether it's that little robot that we've been working with, it's that batteries. Okay, usually lead acid. Although lead acid is heavy, and we'll talk about the different drawbacks of the different batteries and such. There's all sorts of batteries that are used in powering all sorts of devices, not just robots, but batteries are used as a source of power, and as you probably figured out. Hey, Cade. Yeah, Cade, I'm sorry for the technical difficulties. I'm gonna have to make this small again, because if I do one screen, then the other ones change also. And I guess if I had a different browser, but let me mark Cade present. And guys, please make sure that I do mark you present. Okay. Okay, I got you covered, Cade. So, like I said, you know, usually they're in the form of, you know, some type of either permanent battery, you know, like this, or rechargeable, or a battery pack that's rechargeable also, obviously, right? And you know, in the little robots that we use, we've got the little rectangular battery that, remember I showed you it had a little battery sensor on it. This right here, guys, is a battery, and this is really neat because it's got that same type of sensor that I was talking about, showing what the power is, you know, what the power level. These things are fantastic. These pocket juices, I use them to power up my oh, this is not the right type of USB, but I use them to power up like that my my different devices. Okay, and one nice thing about these, and I kind of am going off topic here, is you can press the button. Supposed to be able to press the button, unless it died on us. Guess what? I either shorted it out or I killed it. But this thing's got a light, so I'll be charging this up and see what I can get out of it. Let me do this real quick. Since I went down this hole, and of course I don't find a cable that's suitable for it, because I took everything and and I organized this place. Actually, that's what it means. Yeah, on point. I don't know about on point. I got this little deal right there. I can't see myself because I'm standing up. It was a last minute thing. I had to get it because I had to switch over and stuff. But anyway, point being is that rechargeable. And I'm wondering if I shorted this thing out, or if it was so dead that it just killed it. That's weird. But anyway, I've got a bunch of these laying around where I charge my phone with if I need to and such. But in robots, they do the same thing. They have those battery packs that last forever. There's Carlos. So once again, we minimize everything. Welcome, Carlos. You know, if I was smart, I'd do this in another browser, but we're probably at the end of anybody showing up. All right, so we're only missing a few, so that'll work. But anyway, on with what I'm babbling about. And like I said, we use the individual cells. We use packs of them. We use them in bigger batteries. We connect them. Even single cells, we connect them to form a larger unit, so that we get the voltages or the currents that we need. And of course, there's many types of power sources for robots, and they range from lead acid batteries, which are relatively safe and have a long shelf life, but are heavy, okay, compared to the rest. And when I say safe, I mean whenever you have lead and whenever you have acid, obviously, you know, that can be caustic, right? I mean, acid burns and lead is poisonous. So, you know, what is safe? But I mean, they're very stable. I mean, we've used batteries, lead acid batteries, you know, for a long time. The problem is they're heavy, and but they also have a lot of ampere hours, or a lot of oomph behind them. So, I mean, obviously these look like car batteries, but you can use them. You can use car batteries, you know, in robots if you needed to. One nice thing about it is if you've got a pedestal type of robot, you can put them in the bottom and it keeps it stable, right? And I've seen some robots, man, that are just, they're amazing. And I'll try to put up a link to the last video I saw about some robots. These robots were actually physically shooting handguns, and they were shooting at targets, and you might have seen them too, but they would kick them, they would move them, they would push them. The robot wouldn't shoot the person. As soon as the person moved out of the way, the robot would shoot the target. Very, very interesting. So they're heavier than nickel cadmium batteries or nickel metal hydride, which is what we have. And behind my green screen, I've got a bunch of little metal hydride batteries that I basically recharge and use. Now, see, those type of batteries are smaller in volume and are more expensive. I mean, they are per the output that they have, but they're rechargeable and are easily rechargeable. Let's see, I finally made it. Hey Riley, how are you? It's working. My internet is working right now. Well, welcome. Did I put you in the grade book? I don't think I did I? I don't remember, but I got you now. Welcome, Riley. So nickel cadmium or nickel metal hydride is much smaller in volume, currently much more expensive. Here's a little comparison of let me see if I can make this to where it's a little bit more readable. Here's a chart, okay, where it shows nickel cadmium, nickel metal hydride, lead acid, lithium ion polymer, and reusable alkaline. If you look at I guess this is watt hours per kilogram, the gravimetric density of them, you can see the different numbers. And of course, the bigger the number, the better here, right? The resistance that they have, including peripheral circuit in different ohmages or mega ohmages that they have. The life cycle. Now this is probably more interesting. The life cycle to 80% of initial capacity, basically when you recharge them. The life cycle, 1500, 300 to 500, and this is nickel metal hydride, lead acid, lithium polymer, reusable alkaline. Excuse me. And I ran out of water. How fast do they charge? Fast charge time, 1 hour typical, 2 to 4 hours, 8 to 16 hours, 2 to 4 hours, 2 to 4 hours, 2 to 3 hours. If we look at lead acid, it's 2 to 4 hours, whereas nickel metal hydride is 1 hour, and lithium ion can be, or the lithium ion on the polymer can be 8 to 16 hours. That's a long time, guys. So nickel metal hydride for recharging seems to be the fastest in this category. The overcharge tolerance, in other words, before it blows up, before it catches on fire, before it overheats, before it does something that you don't want it to do, it's moderate. It's not bad. Lead acid batteries, you can throw them on a charger, and usually what will happen to lead acid is you'll boil the water out, right? Lithium ion is not so. Lithium ion, the tolerance is really high. It can accept overcharge. But anyway, the self-discharge per month, that's pretty cool. Lithium ion only has a self-discharge of 5%. So it holds a charge a lot more than, say, a lead acid battery does. Quite more. I mean, so, and you can see what the other ones do right there. Look at this 0.3% on what is that last one? I don't know what that last one is. Is it? I don't know what that column is. Geez, I left that column out. Apparently, I'll have to figure out what that last column is. But the cell voltage on them, If you've kind of looked at rechargeable batteries, they'll be like, this is an alkaline. This actually says 1.5 volts, right? This is lead acid. Relatively speaking, they say the same thing. I wonder what the 6 is. Let me see if the 6 is in here. 6 is 2.5 volt is the open cell voltage. 1.2 is nominally used. There's no difference between the cells. It's simply a method of rating. I've seen these actually show 1.35, 1.4, 1.5, whereas the nickel metal hydride be a little bit lower voltage. But that's the rating on them. If you look at them, if you look at it, it'll actually say 1.2 volts. The load currents, the peak, these are charge. This is what you can pull off of them. This is the best results. So you know, what you can and what you should are two different things. The operating temperatures. Negative 40 degrees to 60 degrees versus negative 20 degrees. So lead acid batteries a little bit less tolerant to low temperature versus you can cool them down even more. The metal hydride. Let me find the chat here. Let's see. It's working. My internet. It's working. My internet isn't working well right now, but you're here. That's what's important, Riley. Yeah, you haven't seen that robot video, huh? See, man, I will find it. I saw it the other day. I think I kind of lost track of it. Yeah, gel batteries too. But they're a form, I think, of a polymer, I believe. I'm not certain. I'm not certain. But the point is there's all sorts of different batteries, guys. Look at the cost factor. Look at the cost factor, which is pretty good. Cost per cycle, like when you recycle them, right? 0.04. And of course, this is U.S. dollars, so you Aussies are going to pay much more, right? So it costs less to recycle. I'm sorry, to recharge a nickel metal hydride than a lead acid battery. So cost might be an issue. In commercial use, what? Lead acid in commercial use since 1990, since 1950? There's got to be something wrong with those numbers. I bet those numbers are backwards right there. There's something wrong there. Not really certain why that says 1990. I wonder if that means, I wonder if that should be 1890 and not 1990. This is a sealed lead acid, lithium. Now this one down here doesn't make sense because that says sealed lead acid for that one right there for the lithium ion. But anyway, some of the characteristics used in rechargeable batteries is internal resistance of the battery, right? The cycle based on the battery receiving regular maintenance, that was number 2. Where's the 2s at? Yeah, see, those are the footnotes that are up in here. Those little numbers. I wish they had a footnote on this one because I think that's wrong. I'm not understanding why lead acid was commercial use since, I bet that's 1890. I'm going to just I don't see anything right off the top of the Google pile, but I mean, lead acid batteries have been used for more than 130 years, so I bet, yeah, I bet that's a typo, and that should be 1890. So basically, these are just footnotes. So this right here, it's interesting to note that nickel cadmium has the shortest charge time. It delivers the highest load current, and it offers the lowest overall cost per cycle. but has the most demanding maintenance requirements. So, but look, nickel, cadmium, nickel. This device, whatever this device was, I don't even know what it was. So designing a battery-powered robot, you need to take into account factors such as safety, cycle, lifetime, and weight. I mean, because think about it. Say it's a lead-acid battery, right? If it's a big battery and you're trying to make a little bitty device, let's call this, other than dirty, let's call this, let me get back on here, right? So, you this thing doesn't weigh anything, right? And I'm trying to find my my broadcast software to make sure. Yeah. So, like this right here. I mean, it's common sense, right? That this has to have a very powerful, very, very, lightweight battery, right? Because, I mean, you can't have a car battery in this thing, right? So, yeah, it depends on your application, obviously, and on the length of time you want it to run. Because I don't even see the battery in this thing. I even forgot how to charge this thing. There's an on-off button there. Wow, this thing is tiny, guys. Here's the port that is used to charge it, and I don't even see a battery in there. So the battery's got to be tiny. Maybe it's a little supercapacitor or something that holds the charge just enough for enough time. I just kind of piqued my own interest. Well, depends the different materials and stuff. There has to be some type of dissimilarities. So there's going to be some type of connection. Let's say something like this: when two dissimilar metals connect, you get some form of reaction in between, and that's a form of resistance, right? So the different compounds will give you that internal resistance. That's really the basics of it. I mean, you have to have something. No, you don't have to have it, but it just occurs. And of course, if you've got distances in between, there's going to be some type of resistance, something to overcome. That's a really good question. And like if a battery, for instance, sulfates, say in a lead acid battery, sulfates, you're going to have even more internal resistance, keeping electrons from flowing from in between the plates in there. That offers a resistance. So designing a battery powered robot, you need to take those factors into consideration. Here's a YouTube. Let me see. Let me see if I can open this up in a new tab. I think here's a little YouTube. I don't know if you guys can hear it. Well,
a lot of people have been asking about powering your Arduinos and powering your motors, and how do they deal with everything. You got servo motors in there, you got some LEDs in there, you got your Arduinos in there, you got your big DC motors. How do you power them? Now, what I like to use, I'm using like these larger-ish lithium polymer battery packs. Sorry, upside down here. This one's a 5.2 amp hour one. And we won't get into exactly all that much about battery chemistries and all that kind of stuff. But I choose these because they're basically very light and high voltage for what they are. These are like a 15.2 volts, but I've got ones that are like 11 point some odd volts. For practical purposes, 12 volts. But then there's also batteries that are like 7.5 volts. This is like 10.5 volts. This guy here, little battery pack I pulled out of a plane. And the issue is, well, how do you power an Arduino with this? A lot of the time, if you've dealt with Arduinos, you may have dealt with.
Can you guys hear that? I think I might have not.
Ward
I think I might have
transformer.
not.
Chances are it's 9 volts.
You know,
Arduino's.
given you. Yeah, you can hear it.
Arduino here. Here's a little Arduino, your basic Uno, and you'll notice in here a lot of people just love to plug in a 9-volt power supply in there, and away you go. The typical Arduinos are basically designed so that you could put 7 to 12 volts in here, and bang, Bob's your uncle, away they go. You can also power them off USB, which is typically 5 volts on here, and that's great if you're tethering yourself to a computer. But in the case that you are actually going to a robot or something that is autonomous and runs around on its own, obviously you want to get into using batteries. So here's one option that I like for certain applications. It's basically, it allows me to put a 9-volt battery on the end of the typical DC jack. And if I plug that in, you will see some activity on the Arduino. Basically lights up, and away you go. Now that's one easy way to do it. And that's fine if, say, you're doing a remote control or some kind of handheld thing. That's fine. 9-volt batteries, they hold a reasonable amount of juice for that sort of thing. But in the case of a robot, chances are you're going to want something more exciting than that. And I have a Mega here. It's the same thing. Same rules apply. Ta-da! Hopefully there's a light on there somewhere. Yep. Away she goes. Now, you can use that same jack if you want, if you have between 7 and 12 volts to power your Arduino. And the issue there is, of course, your battery. Now, a lot of these batteries, they are 12 volts, but they might be supplying more than 12 volts. Some of them even, like I said, this guy's like 15.2. So obviously, I don't want to run that directly into my Arduino. So what do? Now, first off, I should tell you, getting power into the Arduino, not using either of these ports, say instead you want to power it directly. And if you look at your Arduino carefully, on here, you'll see on the bottom row, there's going to be a V in somewhere on there, and you can probably see that better than I can at this point. You're going to see a V in, that's voltage in, and that can generally that can be between say 6 and 12 volts. It's basically on the other side of the power diode and some stuff that's on this side here. So it's a little bit more of a direct route, and this will generally take 6 to 12, whereas people like 7 to 12 on this side is sort of the recommendation. So I generally go in with 6 volts on V in. There it is. It's the last one right there. You already saw that, of course. So let's go 6 volts in there.
Okay, so what I was trying to show there, guys, is that like the Arduino, the way the Arduino. Let me restart this again.
Hey,
well, not so much restart it, but the way the Arduino itself, and I guess I could have an Arduino. The way the Arduino itself, you can plug it in. You can plug it in multiple different places. You can use an Arduino for a robot. I mean, obviously, it's a little microcontroller. You can use it, but the point is the different power, the different ways to power it that you have, and that allows you different ways also to connect different batteries to it. I saw a comment out there that I thought was interesting. Let me get back to it. Yeah, and definitely, Aussie man, thank you for the comment there. Hit that thumbs up, guys. Yeah, give it a thumbs up. Battery technology has advanced so much in the last 20 years, definitely. My phone, your phone, my phone. I've got this this LG right here, and I've got my iPhone. The iPhone, it just charges and stays charged, and we're not talking about 20 years. We're talking about I guess 3 years difference maybe. This one I'd have to charge every day and keep it charged, and by the end of the day maybe it might be out. This one I can go 2 days without charging. And one of the neat things with this one, there's also what's called inductive charging. And this thing is a fast charger, wireless charger. They call it wireless, right? But you can take and you can put this on here. Yeah, there we go. And that little puppy's charging now. And that is the neatest thing in the world when you can do wireless charging or inductive charging. But anyway, wireless charging by just placing it. And it's been around for a while. It hasn't, it just didn't appear overnight. But that same technology has been around for a while. It's like, say for instance, and remember, guys, I have said, and this is just falling all over the place because that's not where that belongs. So I took its place. Remember, I said that everything's melting together, everything's coming together. Take a Tesla automobile, or take an automobile with a battery up underneath it, right? Or a robot for that matter. Okay, the Borgs in their Borg cube go to their station to recharge or to recycle. But my point is that robot or that automobile or that device goes over a charging pad of some kind. You drive it into the garage. You get out. It charges. You don't have to plug it in. Your robot. Your robot, when it's getting low on power, knows to go back to the point where its charger, and it's either going to physically hook up and charge up, or it's going to be inductively charged like that. Hold on. You mean the charger? I'll show you the charger. If that's what you meant. And there is a latency. I'm going to look at ultra low latency next time that we do this, guys. Tell you what. Let me just go ahead and do it. Let me drop this guy out. I don't know if you can actually see it because of the green screen, guys. Let's see. Let's see if see, the green screen's messing with it too. You can kind of see that. But if I put this on here, and I'm trying to see how it glows down here. See how it started glowing? It's actually charging it right now, as opposed to when I take it off, it goes off. It's still glowing actually, but and it makes noise. See? Yeah, the green screen. You have to actually put it on there, right? See, I haven't heard it make its ding noise that it does. But anyway, enough of that. But that technology is also there. So you could even think about incorporating something like that. Let me go ahead and minimize this because I know you don't want to look at my ugly mug. Make me real small. Let's see, make me really, really small. No. So let me go ahead and bring back this document that we were looking at. Let's see, where is it at? I lost the document. Did I lose it? Because that can go away. I just have it on a different page. Where is it? Where is it? Where is it? Yeah, I moved it over here. Here we go. So I wanted to show that video right there. Watch the whole thing. I only did just start to end. You can also use generators to power, and they're often used in internal combustion engines, right? Let me make this a little bigger. Let's see. Brandon says, I wired a 220 volt charger for a Tesla manual plug. Yeah. Your screen is toughened glass. Yeah. So is the green screen messed up because I messed with it? Yeah. Let's see. There we go. There we go. Now I'm squared in there. Um, too funny, Aussie man. Um, uh, so I want to ask you what you did or what you did. I mean, you just actually took the 3 or the 4 prong connector. Is that what you wired? You know, I'm wondering. I'm wondering if that's actually what's in here, but I don't know because, like I said, this really lasted a long time, and I don't know. I don't know if I actually shorted it out or if it just discharged because it hasn't really been charged in such a long time. You know, it goes to a certain point, and then all of a sudden, it powers itself off basically. um, I might have shorted it out, and you know it's funny. I don't have a cable here because I took and I charged things up, guys. That's what happens when you charge. I mean, when you organize things, you can't ever find anything. At least in my world, it's that way. You know, this is a USB cable that has USB 3 and USB 4 on it. It's a weird cable at the one end. Um, so going back to the document, you know, generators are usually used in internal combustion engines, right? Um, because you have a source of movement and some form of mechanical to electrical power conversion. So that's one way to charge batteries. So if a robot were moving, you could, in essence, do it. In fact, some of the electric vehicles do a regenerative braking system to where when they're braking, they're taking that energy and rotating, you know, a counter inductance field that basically charges the batteries up. So, or helps to charge it up. Of course, tethering or connecting a robot to a power supply. I've got a little robot that has a video and it's tethered with a USB cable. Well, that's how it's getting its powered. But that's not very practical when you think about it because a robot has to be, you know, something that moves around. But if it's a stationary robot, you have access to things like that to where if it's a claw that moves back and forth, well, you can have it physically wired. Um, I know Tesla's older cars use standard 18650 cells. Yeah, it had trays exactly under the car, and one of them discharged, the whole car will shut down. Yeah, they're going to battery system. Yeah, yeah, counter. Hey, Jim Shears. Jim Shears knows a lot about electronics and a lot about controllers and robotics and the Internet of Things. Because one of the things I like to say is, you know, things are coming together. Everything is becoming the same thing, basically. And if you think about it, yeah, it might have a nice, pretty little shell, you know, on the outside, but inside it's the same thing. Like, for instance, the Internet of Things. You've got a sensor, you've got a controller, and you've got an actuator. And what else? Think of everything that you know of, and that's it. I mean, that's it. There's only one fourth or a fourth thing, and that's storage. And that's a computer, by the way. Input, output, storage. Um, so yeah, charging station to the wall. It had a weird plug. Oh, okay, Brandon, I see. Yeah. Yeah, you know, there'll be all sorts of standards for all sorts of different plugs. Some proprietary, some made for specific reasons. Some are actually standards that evolve, you know, through time. There's standards that are come up, you know, that they come up with. There's standards that are just used because that's what they've always used. So yeah. And what I was saying, going back to it, an internal combustion engine's got an alternator or a generator in it, and it's easy to tether the power supply or attach the power supply to it that way. But you know, if it can hold the weight, you know, if it doesn't have to move, that's the way to go. But anyway, there's other. Let's see, what time is it? I'm not going to go on too much. There's other things like pneumatic, like solar power, and that one right there is a totally, a totally, a total class basically. The pneumatics one, I'm not a pneumatics expert, but I'll give some information on pneumatics. In fact, I might be able to do that tonight. The solar power one, I'm not going to go into tonight. The hydraulics, I think I'm going to do hydraulics is what I'm going to do, which hydraulics is pretty cool. I'm not a hydraulics expert, but I'll see if I can find the document that I was working on. And then there's organic garbage or anaerobic digestion that creates power. And of course, the big bad boy, right? Nuclear. That's another way to power a robot, right? Or anything for that matter. Let me see. Fluid power, force pressure, hydraulics. I don't remember where I put the document, to be honest with you. Oh, yeah. Yeah. Is it this one? Is it this one? This one really wasn't the one that I was thinking about. Let me see if it's this one. This is a video that's in here that'll be really cool to watch. It talks about force. Let me see if I can make this bigger. It talks about force. I lost it. Yeah, it talks about force, pressure, and area. So basically, the force that you exert is one component, pressure, and then the area. The area being of the piston, and that's the way you have movement. Like I said, I'm not a hydraulics expert. Let's see what else was in here, and I don't think I released any of these. I think we did the controlling the drivetrain last night, or not last night, but last time. Yeah, that was it. That was the one that you guys. If you haven't done this, you need to do. That you guys did the port, and it's port 1 and 10, right? You defined the 2 ports, and then you created the two motor drivetrain, and then put it through the see, with the instructor sign off, put it through the I want to call it obstacle course. It's not really an obstacle course. Let me see if I can find something that we did. Is it in my photos? Try to remember. Let's see if we can get a date out of these. 28 movie, no. I'm hoping that I can see this because I think you guys know where I'm going with this. I hope you do. Let's see. See if I can see this. Because some of you didn't see this, and then most of you have done it, I think. Let's see. Is it even in here? No. Well, might not find it. Let me look at details. View details, and then let me modify it by date. Last time was the 11th, so this goes back to 2/11, and it was a movie, and I don't remember which one it was. There's 3 movies here. I wonder if it was this one. Since this one's the biggest one, I wonder if I can play this for you guys. Nope, that's not it. That's Gorilla Glue. Oh well, that's not what I wanted. Let's see, 9 a.m., 10 a.m. That's interesting. It's not in here. Oh wait. Should be a movie though. $9:49, 1 p.m. No, this is 13. That should have had a timestamp, though, of the 11th. Why doesn't it have a timestamp of the 11th? What am I doing wrong? It's interesting. My movies only go up to the 9th, 129, 129. Oh, well. Anyway. All right. Oh, there's 112, 111, 9:50 p.m., 9:45 p.m. I wonder which one of these this was. Maybe one of these two are it. Nope, that's not it either. Oh, that one isn't it. Oh, goodness. I know Jim's seen this one. Anyway, you guys know what this is. So, we just experienced this last yesterday, last few days. So let me catch up. Don't put on your hair. That's right, Brandon. That went a long way. Yeah. You guys got the drift on that one. Let me see. So don't put that on your hair. Some older ones have natural gas driven motors in lieu of electrical. Yeah, because there's another power, Christopher Sims, for sure. There's another way to power. Like generators for a home, they can be gas powered for sure, but the big systems, they have natural gas going to them. Can you think what happens though when the gas supply stops? I guess Jim took off, which is see you later, Jim. Just how I was streaming. Hey, yeah, man. Thanks for stopping by. You're always one of the cool kids, Jim, no matter whether you stop or not, but thank you so much. I think I'm going to cut it here too. And I'll give you guys some more information later on. Hopefully the next time we meet will be face to face, guys. It's a little easier to be face to face also, or all, for sure, instead of this. Thank you guys so much for the participation. Make sure that if I didn't mark you down in the grade book, please bring that to my attention. Christopher Sims, I think she's got a manager now, I believe. So, Ozzy, man, thank you for stopping by too. You're more than welcome to join any of the lectures that I do for the class. This one just happens to be because of the situation that we've got. Yeah, why not? There's a, and I'm not too well versed on them, but there's a technology called a Dyson sphere that supposedly, maybe it's a little more science fiction than reality, but supposedly it's a structure that you sit around, like a sun, and it somehow, gathers power from it. There would be, wouldn't there? And yeah, the actual movement of a planet, why not? Or planetary movement, or gravity. I mean, there's things like solar sails, right? That the sun, I don't know what to call it, the sun wind, the sun, the particles coming off of the sun that keep traveling, they keep hitting it, and in space, for instance, since there's no resistance, it just keeps going faster and faster and faster and faster, right? So there's all sorts of ways to power a robot. There's also all sorts of ways to power, pretty much anything. There's all sorts of ways to convert different energies back and forth, like in the sense of a mechanical energy into electrical energy or something like that. What does that sound like? Well, a battery, right? or electromechanical, I guess. But anyway, you want to be special? No, don't be special. Don't be special. You don't want to be special that way. Yeah, and no matter with what form of energy, okay, whether however we're garnishing, there's going to be trade-offs. For every action there's an equal and opposite reaction, right? So there's going to be trade-offs no matter what they are. Orbiting satellites, yeah. I mean, guys, the sky's the limit, So, well, anyway, I want to end it right here. Thank you guys so much for being here, and the special guests that we had attend. Those are definitely awesome, guys. Thank you so much for being here, and I guess I'll see the class. Hopefully, everything should melt. Everything should get powered back up next Thursday at 8 o'clock like normal. So, does anybody have any questions? If not, then we can all adjourn to our warm homes, hopefully. And I'll kind of wait a little bit to make sure that nothing is coming through in the form of a question. All right, Chris, or I'm sorry, Riley, see you later. Jeremy, you have a good one too. And you guys definitely stay safe. Oh, thank you very much. Definitely I'm staying warm. No matter what, we're constantly all learning. Technology is changing constantly. No worries, Riley. I know I'm taking attendance, but I'm going to be really, really lenient. That's not a problem. I understand. I really do. That's just a formality, Thank you, Leon. See you next week. There'll be more with the robot. I guarantee you. More stuff to do with it. It's gonna get fun. Bye, Brandon. You guys can take off. I'm just sitting here watching the chat and watching the current viewers go down as you guys leave. So in case somebody does have a question, I'll still be here. I'll probably be one of the last ones to leave. So thank you, Enrique. See you, Brandon. Okay, so it doesn't seem like there's any questions other than goodbyes and such, and it doesn't even seem like there's any more of those. So I'm going to just go ahead and stream, guys. Like I said, have a nice one. Stay safe. See you guys later. Bye-bye.